So good afternoon, everyone. So it's like rainy season in Delhi. Every day we are having rainfall. Last year also there was like nowadays if you compare it from 2015-16 to the present times, we'll find that like it is increasing year by year. You will find that there is more and more rainfall in Delhi. Like over the last 10 years, it is increasing continuously. Okay. So maybe we are planning to have more and more lakes in Delhi. Okay. So and see there is one at least there is one good thing. Due to these rainfall, you are not having that much of water scarcity in Delhi in the summertime. There is intense rainfall, and from the last 2-3 years, there has been lesser water scarcity. During this time of COVID and 2019, when there was scarcity of rainfall, it was very much crisis that many of the pumps, the submersibles, they were not working. But now we have lakes also in Delhi. Okay. So what we were discussing in the last session, we were discussing about this one part, vaccines. Yeah. Till now, what we have discussed, we have discussed about this one part, that is what is medicine. We have discussed what is branded medicine, what is generic medicine, what is branded generic also. We have discussed about this one thing called as antimicrobial resistance. What are the factors which are responsible for it? Plus, we have also seen that what government steps have been taken in this regard. At global level also, we have seen the suggestion of WHO. Like what is the WHO suggesting about this? That if we have to control this AMR, the antimicrobial resistance, then what we have to do. So this is one part which we have discussed. Then we have started discussing about this second part, which is about the vaccines. We have seen this one thing, like what is the use of the vaccines, what they provide to us. Now, we will see there is one mains question also which I would give you here, which you can try to write. Okay. This is one first question. Distinguish between the branded and generic drugs and evaluate their merits and demerits. This is one such theme on which UPSC is asking questions. Okay. There is this one such approach of asking the question. They have been asking that evaluate the merits and demerits, especially in the technologies. Like if we see in 2024 also, there was this one question that for toll collection on national highways, what technologies are there? And then they were asking that like evaluate their merits and demerits also. In past also, other questions have been there where you are asked to evaluate the merit and demerit of a certain technology or certain things. Okay. So this is one part. Distinguish between branded and generic drugs and evaluate their merits and demerits. Do you think that there is a need to promote generic medicines over branded drugs in India? Justify your answer. So see, now this is one part where you will have to use your analysis skill. You have to use your analysis skill here. Question is asking, do you think that there is a need to promote generic medicines over branded drugs in India? And justify your answer. So you have to give some arguments in the favor of it also. You have to give some argument against it also. And then finally, in the conclusion, you have to balance that on one hand, we need to promote the generic drug, but at the same time, we have to promote the branded drugs also. Because it is about innovation, it is about finding new medicines. If we keep on promoting just the generic drug, we will be just following the international trend. We will not be creating our own medicines. We will not be developing the medicines. So this is one part. You will have to do your use of your analysis skill, how you write this part. Third thing is this. Second question. What do you understand by the antimicrobial resistance? Highlight the factors responsible behind the rise of AMR and give an account of steps taken by India to control AMR. So here I am giving you question on the same line as what UPSC asked. UPSC is not asking about discuss, examine or anything in case of science and tech question. They are simply giving normal questions. Normal statements are there. So on that basis itself, you have to prepare. So you can write these two questions easily. You can write? No. Okay. So write them, write these two questions. Now, after this portion, answer me a few questions here also. Consider the following statements. A person suffering from Klinefelter syndrome will not have any child. A woman suffering from Turner syndrome has very little chances of having pregnancy. Trisomy X results in abnormal taller body in males. How many of the above statements are correct? How many are correct? A option or B option or C? Or D option also? See, here if we look at this, a person suffering from Klinefelter syndrome will not have any child. This is an absolute statement. Okay, there may be somewhat infertility, but this is an absolute statement that will not have any child. There may be difficulty in the process, but it is not a sure shot guarantee that there will not be a child. Okay. Then it is saying a woman suffering from Turner syndrome has very little chances of having pregnancy. So this is correct one. Because in Turner syndrome, there is only one X chromosome, so it is quite difficult to have a child or have pregnancy. Trisomy X result in abnormal taller bodies in males, in females. Yeah. So here we see that the third one is also incorrect. Answer is option number A. Color blindness is mostly prevalent among males. It is a chromosomal defect in males due to defect in genes associated with Y chromosome. Thalassemia is also associated with sex chromosome defect. So how many are correct? Color blindness, first is saying it is mostly prevalent among males. So I think you know this part, that this one is correct. Second one is saying that it is a chromosomal defect in males due to defect in the genes associated with Y chromosome. It is related to X chromosome. Third is saying thalassemia is also associated with sex chromosome defect. Thalassemia is something which is associated with autosome 16. Okay. It is similar to sickle cell anemia. It is similar to sickle cell anemia. Only in sickle cell anemia, what we see that it is sickle shaped. And in case of it, it becomes almost like this. It is also stiff. It becomes rectangular shaped. So thalassemia is also one problem associated with autosome number 16. Now you will say that I have not taught you this. Thalassemia. UPSC has also not provided you syllabus. Okay. So UPSC is asking from anywhere. I can also ask from nearby regions. Okay. So thalassemia is one thing associated with autosome 16. Okay. So here if you look at this, the second one is this incorrect. First one is correct. Answer will be option A. Antimicrobial resistance arises due to indiscriminate use of medicines. AMR makes disease difficult to treat. AMR develops only due to overuse of medicines by humans. I think now you can answer this easily. Yeah. A option or B or C? D. So this one is correct. Second is also correct. Third is incorrect because it is not only due to, there are multiple other factors. So answer will be option number B. We will see more questions with respect to medicines later also. Now we are starting with this one part, vaccines. We are starting with this one thing called as vaccine. Last day I told you that how the vaccine work. Last day we have seen this one part, that how the vaccines work. We have seen this one part, that when they come to our body, when we are injecting the vaccines in the body, they help the body to generate an immune response. At the same time, some of the cells of the body keep that in memory as well. And as a result of this, vaccines help us in preventing from the infection. But at the same time, is it a sure shot guarantee that there will be no infection in future? It is not so. Okay. Vaccines help us in preventing infection in most of the cases, but that is not absolute that there will be no such infection. Why? There is still a chance of infection because viruses also evolve. There is variation in viruses also. Their genetic makeup also changes over a period of time. And as a result of that change, what may happen that some of the virus may also develop this immunity against the vaccines. Like in many cases, you may have seen that people have taken vaccines for chickenpox or smallpox, and still at some point of time they might be having infections with respect to this. Then at the same time, like if we talk about the flu, the normal flu, even if you have taken a vaccine of it, flu changes rapidly. And that's why there is a possibility that after every 2 or 3 years, despite taking flu vaccines, people may still have flu. So some viruses are rapidly changing, and as a result of that, what we see that there may be infection even after taking the vaccines. Now, we will see first this one type of vaccine which is called as inactivated. Inactivated. In this case, we are taking a dead bacteria or inactive virus. Like suppose if you are preparing a vaccine for a bacteria, it can be prepared for bacteria also, it can be prepared for virus also. If we are preparing a vaccine for a bacteria, what we see that we have to take a dead bacteria. Or if we are taking a virus, we have to take an inactive virus. Virus should not be active. Virus is not considered dead because it is not living. Okay. So it has to be an inactive virus. Now, why we don't create so many vaccines for bacteria? Because bacteria is something which can be killed. Even if it is causing infection, we can kill it. So we are not working on developing the vaccine, rather we are working on developing the medicine. Okay. We develop medicine for the bacteria and vaccine for the virus. This is one normal trend. We generally develop this vaccine for virus and medicine for bacteria. Because you can kill bacteria, but you cannot kill virus. For virus, we have to develop the immunity. So normally, in this case, we take an inactive vaccine. Here we are taking an inactive virus. Inactive virus. When this inactive virus goes in our body, there is very little chance of infection. There is very little chance of infection, very rare, quite rare. Okay. That 1 in a million chance of having infection. So this is one thing which is quite rare to cause any such infection. Even if they go inside the body, they will not be so much powerful that they can cause any infection. But when the body recognizes it, when the body is seeing this one thing, that there is a presence of a virus inside the body, they are going to prepare a defense against it. Always remember that one part. If something foreign comes in the body, body is not going to accept it. If something from outside is coming in the body, body will not accept it. So here also there is the same logic. If a virus is going inside the body, body is going to prepare its defenses. It is going to prepare its defenses against this virus. And some of the cells are going to retain that defense in their memory. They are going to retain that in their memory also. So this is another part. They are going to retain it in the memory. And later on, if there is an actual infection, If there is an actual infection, so then they are going to fight back. They are going to like provide that immunity to the body. So this is one part. They retain this fight back mechanism in the cell, and later on, we see that they will use the same thing to attack any incoming virus. So that is one general approach. Now, second main type of vaccine is live attenuated. Its name is live attenuated vaccine. Live attenuated vaccine. Here the virus is going to be active. Here the virus is going to be active. But at the same time, this virus is not going to be very much powerful. Here we will take a live virus, means one which is active, but it is not going to be very much powerful. So why we are taking this? See, just take an example. There are two things which has been identified by police. Yeah. Let us say in our general life, we have identified two things. One, there has been identification of a bomb which has already been diffused or which is not active. Second, a second bomb has been identified which is not very much powerful, but it is still active. In which case, there will be a strong response or quick response. First case or second? First. Like there is a active bomb, even if it is less powerful, there will be quick response. And there will be a very strong response. Everyone will try to find out where this bomb came from. But if it is a diffused bomb, then there will be some bureaucratic like inquiry, and then like they will just keep it in mind that okay, some bombs are also coming, but they are not active. So here what we will see that here we are using a weak virus, weak but active. And in this case, there is going to be a very strong response. A strong response. This is going to generate a very strong response. But if we compare both of them, which one is going to be risky? Live attenuated or inactivated? Live one? Okay. So here what we see that it is more risky as compared to, this one is less risky. So this is the one part that in inactivated vaccine, we are having less risk, but the immune response is also not very strong. Here we are having more risk. Here we are having the more risk in case of live attenuated, but at the same time, what we will see that there will be a very strong response which is generated in this case. Okay. So more risk, more gain. That is the simple concept. More risk, more gain, less risk, less gain. So that is two main types of vaccines which are very much common. During the time of this COVID, there were two vaccines which were very much popular in India. One is Covishield and second was Covaxin. So Covishield, like if we talk about this, Covaxin was the type of inactivated. Covaxin was the type of inactivated vaccine. What about Covishield? There were two vaccines which was very much famous initially. Later on, we have seen the mRNA vaccines also come. Many other vaccines have come up. Covaxin was this inactivated vaccine. But when we talk about Covishield, it was not live attenuated. It was a different type of vaccine. Covishield was based on this concept that we are going to deliver the spike protein with the help of a viral vector. Here we were not like directly putting the live COVID virus in people. At that time, no one was going to take that risk. If you remember the time of 2020-21, at that time, if you were telling anyone that we are putting a little bit powerful COVID virus inside your body, how many people will go for the vaccine? Yeah. So either there was inactive vaccine or the spike protein. Yeah. So there is another part. Okay. There is another part of vaccine which is simply called as viral vector. Viral vector. Here we are using a vector. Vector means the one which can carry a particular trait to somebody. So here we are using use of a vector. Vector means someone who can carry the information. Okay. So in case of COVID virus, there was a spike protein, a protein which was responsible for binding with a cell. Like normally if a virus is infecting us, they bind to the cell. They try to enter the cell. And for that, they are using a protein. So that is called as a spike protein. So in case of COVID, the spike protein was identified and that spike protein was delivered using another virus. A virus which will not be harmful to the human body. So we choose another virus and with the help of that, we were only delivering the spike protein. Okay. So here we have seen that like delivery of genetic traits or proteins with help of a vector. With help of vector. So this is one such area like where we are not using the live virus or even the inactivated virus. We are not using either the live or the inactive. We are using just a component of it. And using a vector, we are delivering it to the body. So sometimes they are simply written as vector vaccine. Here we have like written especially viral vector. So viral vector means the one where we are using a virus as a vector to deliver the proteins or the genes of a virus. Okay. So here we are not using bacteria. We can use bacteria also. There is a possibility that we can use bacterial vector. We can use bacterial vector also or any other vector. So we are using something which is not harming the body. Using that one, we are delivering just the message. Okay. So in case of this viral vector, we can use the protein also. Sometimes we can use the genetic components also. Sometimes we can also use like the mRNA also. So all these things are possible with respect to viral vector. There is another type of vaccine which is called as mRNA vaccine. And then we have the DNA vaccine also. So here it is quite clear that when we are talking about mRNA vaccine, we are neither using the active nor the inactive. We are just providing the mRNA of that particular virus. And what is mRNA? mRNA is basically an instruction. It is a code. Okay. So here we are use of mRNA to deliver the information. So here we are using the mRNA to deliver the information about the virus. Now, what is the benefit here? In case of mRNA, what is the benefit? If we compare it, mRNA is something which can be synthesized in lab. Like you cannot synthesize a virus in the lab. You cannot synthesize a virus in the lab, but you can synthesize a mRNA in the lab. mRNA is a chemical formula. You can easily multiply it. There is one thing in genetic engineering, PCR, polymerase chain reaction. Using that, we can multiply the genes. Okay. So what we can do is, we can multiply the mRNA at a rapid scale, at a very enormous scale. In a very short period of time, we can make bulk of vaccines. If you have seen that phase when the vaccines were introduced in 2021 in India, for initial few months, it was available only to certain section of the society. It was available only to those who are senior citizens above the age of 60. And then later on, it was expanded to other people. Yeah. So what we see that it was not made available to everyone. First, it was given to high risk population. And then gradually it was expanded. Why? Because we have limited capacity of its production. We cannot produce as much as we want. But in case of mRNA, we have the possibility of doing mass scale production of mRNA vaccine. We can do the mass scale production because it has to be synthesized in the lab only. But tell me one thing, if we compare them, here we have inactivated, live attenuated, and mRNA. Which one is going to be more effective? We have three things. One is inactivated virus, one is simply live attenuated, and mRNA. Which one will generate the strongest response? It will always be live attenuated vaccine. In fact, among all the vaccines which are there, whether it is DNA, RNA, or any type of vaccine, remember one thing, there is one such vaccine which provides the strongest response, and that is live attenuated. Why? Because it is a direct threat. All others are information of threat. All others are information of threat, and it is a direct threat to the body. It is not just information. If body doesn't act against it, it is an actual threat. It can cause infection. Here in case of mRNA, what we see that the chances of infection is quite rare. In case of mRNA, there is very rare chance that there will be infection. That person who is infected from mRNA vaccine, he has to be really very, very unlucky. Then only it can happen. Like, think about this, mRNA is the safest mode, and if someone has got infected from mRNA, it means his time is not going right. All his planets and everything is going in wrong direction. Like normally, if you go to any astrologer, they say that your Shani Graha is not good. So his all Graha is not going in the right direction. Then he will be infected with mRNA vaccine. So that is the case here. This is one of the safest, and this is something in which we can go for mass production. So that is one thing which we see with the help of the mRNA vaccines. So here 4 vaccines which we can see here. One is inactivated, live attenuated, viral vector, mRNA, and DNA. DNA just simply use of DNA to make virus. Okay. There are some DNA based virus or bacteria. We will use their DNA to make the vaccine. This is also same as mRNA. Only difference is instead of mRNA, we are using DNA. So that is the only difference here. It will also be safe. It is also not going to cause infection. We can also synthesize it in lab, and we can do mass production. So this is one thing, like how we are evolving the different types of vaccines. So write a little bit about this. First, write the heading vaccine. You can write it point by point in that vaccine topic. Vaccines provide immunity to the body, by training the immune system, by training the immune system to fight against any risk. Vaccines introduces bacteria or virus inside the body. bacteria or virus inside the body. These infectious agents are generally weak or inactive. These infectious agents are generally weak or inactive. When they enter the body, when they enter the body, when they enter the body, the immune system generates, when they enter the body, immune system generates antibodies to fight against them. Antibodies to fight against them. At the same time, some of the cells of the body retain the defense mechanism in their memory. Retains the defense mechanism in their body or in the cells, in their memory. Okay. When there is an actual infection, next point, when there is an actual infection, the immune system uses that defense mechanism to fight the infectious agent. Next part, write this. Types of vaccines. In types of vaccines, first write about this one. Inactivated vaccine. Here you can write point by point. Use of inactive virus. First point, use of inactive virus or dead bacteria. Use of inactive virus or dead bacteria. Here you will write one thing. A strong response is generated. Not very strongest, but a strong response is generated. Strong response is generated. Less risky. Less risky. Less risky. Okay. Give the second part, live attenuated vaccine. Use of weak but active. Use of weak but active infectious agent. Use of weak but active infectious agent. Here you will write a stronger response. A stronger response. A stronger response as compared to inactivated vaccine. Stronger response as compared to inactivated vaccine. And third point, more risky as compared to inactivated. 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 More risky as compared to inacti Third part, viral vector vaccine. Viral vector vaccine. Here, use of a vector agent, and in bracket you can write bacteria or virus. Use of a vector agent, in bracket you can write bacteria or virus. Second part, usually carries genetic traits or protein, usually carries genetic trait or protein associated with the infectious agent. Then in this you can write little or no risk of infection. Little or no risk of infection. Then write this part, mRNA vaccine. mRNA or bracket DNA also you can write simultaneously. mRNA or DNA. Here you can write use of mRNA/DNA. Use of mRNA/DNA to deliver the information about infectious agents. Here you can write in this part, it can be mass produced. It can be mass produced in small amount of time. It can be mass produced within a small amount of time. Small period of time or small amount of time. Okay. It can be mass produced. Mass produced means at a bulk level. Mass production. Response, in that case you can write like response lesser than inactive or live attenuated vaccine. Response lesser than inactivated or live attenuated vaccine. Now tell me one thing. If we have to compare, there are three vaccines. If we have to compare, one is like inactive, one is live attenuated, and one is mRNA. Like suppose we are having three different vaccines: inactive, live attenuated, and mRNA vaccine. If we have to give a vaccine to a population which is young, if we have to give this vaccine to a population which is young, which is more suitable? Young means like, how will you define young? 15 to 49 years approximately. Or chalo, let's like now 40 years, 15 to 40 years of population. So which one will be preferable? They will risk the future generation. Yes. So in the case of young population, the live attenuated is considered a suitable one. Why? Because it can generate a strong response for a longer period of time, and those who are generally in the young age, they have a higher immunity also. So they can sustain it, they can easily overcome the infection. So this is one such preference. In case of senior citizens or those people who are having some pre-existing diseases, which one will be more suitable? mRNA. So in senior citizens, in those people who are senior citizens or those who are already having some sort of disease conditions, then mRNA vaccine is more suitable. So from here you can understand this one part, that why we are developing different type of vaccines. Why not focus on only one type? Because we have different type of population, and for each of them different type of vaccines are more suitable. So that's why for mRNA we can see those people who are of old age or those who are having pre-existing conditions, they can be given this mRNA vaccine. Those who are young age, they can take the live attenuated one. And earlier we were using this inactive vaccines also. In fact, most of the vaccines which we have got, they are the inactivated vaccines. Most of the vaccines are inactivated. In certain cases, we are using this live attenuated, like Incovac, which is still in trial phase. It is a live attenuated vaccine. Covaxin, which was there, it is a inactive. OPV, the polio and others, they are also inactive. Okay. So this is one part. What are the different type of vaccines? Later on, when we will see this genetic engineering part, we will see one more type of vaccine, the conjugate vaccines. Okay. So that is a new type of vaccines which have come up. It is nothing special, only we are combining some genes together. So that is a conjugate vaccine. It can be protein based, it can be DNA based, or anything based. So there is a later thing. There is also recombinant vaccine. So recombinant is based on the recombinant genetic technology. So there are certain vaccines which are based on genetic engineering also. So when we will see this part of biotech, and when we will complete this portion, then we will see them also. That what is recombinant vaccine, what is conjugate vaccine, what is subunit vaccines, etc. Okay. So these are the common vaccines which are there. The common vaccines. Commonly we have got inactivated, live attenuated, viral vector, and mRNA. Or sometimes DNA also. So they are the vaccines which are there. So this was your part of the section of bio. Okay. In bio, what we have started with? Cell. Then we have seen the kingdom classification. Then we have talked about human body. We have talked about the diseases section. When we have seen about this medicines and vaccines. Okay. So these are 5 sections which we have seen from the basic part. The 5 sections which we have seen from the basic part. The remaining portions of biotechnology, we will see it a little bit later after completing this section of general science. Okay, like some parts of physics and chemistry, and then we will see this part of biotechnology again. We have 1 week approximately 1 week in which you have to revise it all, like especially the cell chapter. Okay. Why? When you have understood the cell, you can easily understand what goes in genetic engineering. We have already seen a background of it, that there is something called as DNA, there is something called as RNA, what is their role. We have already seen that what is chromosome, genes, what is genes, genome. We have seen these sections. Now when we will come to biotechnology, it will be much more easier. Okay. We have also seen one thing, phage therapy. If you remember, last day we have discussed about this phage therapy part also. So this is one section which we have covered. Revise these all, and on the basis of this, we will start with biotechnology. But before we go into that, there are certain portions of general science which we have to cover first. Okay. In physics, the topics which we will be discussing, one is about the force, one is about the light, electricity, sound, electricity and magnetism. Here also you will see one topic which is there in although it is part of geography also, but it is something on which question can be asked in prelims as well as mains. We will see about the thunderstorm, the science portion. Okay. So this is one thing, electricity and magnetism. Then we will see this portion of sound. Okay. Then after, we are also going to talk about this one final part, universe. So these are the topics which we will see in the section of science, physics. In portions of chemistry, we will see just this general chemistry, and this some elements and compounds in news. Like this year, there was 2 questions from science, and both of them came from this section only. Like we have been discussing these 2 things for a very long period of time. One was like this critical minerals. Okay, we have discussed it from the mains angle as part of chemistry also, and rare earth elements. So we have discussed both these things, and this time 3 questions were there. One was from virus, like our famous virus, and then we have 2 questions, one from rare earth elements, one from critical minerals. So in 2025 also there were still questions. So we will see this portion, the remaining portions here on from physics and from chemistry. So which one is more interesting? No, I'm talking about the topics in physics. Universe. So we will start with force only. It doesn't matter what is interesting. Okay. Interesting things are not asked in examination. Okay. They have asked from chemistry, and none of you are saying chemistry is interesting. Okay. So they have asked from chemistry portion that what are rare earth elements and what is critical minerals. Okay. About rare earth element, there has been question in mains also, because it has become very famous in the present times. Rare earth elements have become very much famous. So in 2018 itself, there was a question on rare earth elements. So if UPSC will ask about interesting thing, they will ask about comedy nights with Kapil Sharma. Okay. So they are not asking about it. So see, in the case of force, we are not seeing like what is force, what is velocity. I think you have know that. Okay. If you don't know that, start running, you will find velocity. Okay. Start running in like a straight line, you will get the speed. If you start running in a circular line, you will get the velocity also. You get angular velocity also. If you want to check what is inertia, go and sit in the DTC bus. You will realize inertia of state also, inertia of motion also, direction also. Okay. Because when they are turning around the corner, you will experience all the type of inertia together. Okay. So there are some inertias which may not be even like they're in the book. You can witness that also. Inertia of altitude can also be witnessed there. Okay. So if you want to check all those things, you can go there. Now, in case of force, we have to discuss 4 different things. One part which we are going to see is there are 4 fundamental forces. There are 4 fundamental forces in nature. Fundamental because they exist without any other thing. Okay. No one is applying them. They are there since the beginning, and they will be there at the end also. So there are 4 forces which are responsible for the existence of universe itself. They are responsible for the existence of universe itself. Each and everything which you see around you is because of that force. Okay. So one of that force is gravitational force. There is another force which is called as electromagnetic force. There is one force called as strong nuclear force. Strong nuclear force and weak nuclear force. Strong nuclear force and weak nuclear force. So these are the four forces which we are going to talk about. First of all, the gravitational force. Okay. So gravitational force, if we talk about this, why does it exist? Why there is a gravitational force? Does this pen have gravitational force? Okay. One question, does this pen, not the earth, I'm not asking about the earth, this pen, is it going to have gravitational force or not? So will it attract the earth toward itself? If this pen is there, will it attract the earth toward itself? It will attract. Okay. It doesn't matter if earth is moving toward this or not, but it is going to attract. Okay. So gravitational force is basically a force of attraction. It is always and always a force of attraction. And this force is existing because of mass. Like by virtue of mass, by having a mass in any object, there is going to be gravitation. If air is there, will air have gravitation? The atmosphere which is there, will it have gravitation? So it doesn't matter whether it is solid, liquid or gas. It doesn't matter whether it is solid, liquid or gas, each and everything is going to have gravitation. In fact, those objects which have one of the highest gravitational values, they are made of gases only. Like look at the sun. Sun is not made up of solid substances. Sun is made up of hydrogen and helium gas. And sun is like thousands and thousands of times having more gravitation than all the planets combined together. Not Earth. All the planets combined together don't even form 1% of sun. So this is one part, like whether it is solid, liquid or gas, a small substance or an enormously large substance. If they have mass, they are going to have gravitation. It can be negligible. It can be negligible, but it will not be zero. If a substance is having mass, it will have some amount of gravitation. So gravitation is first thing that it is by virtue of mass. It is first thing by virtue of mass. And second thing is it is always a attractive force. Means it is always going to attract something toward itself. So we see that this first two part about gravitation, why does it exist and what is the nature of it. Now the third part. When we talk about gravitation, it is considered as the weakest force out of these four forces. It is the weakest one. It is the weakest force of the nature. There are four forces in nature: strong nuclear, weak nuclear, the electromagnetic and gravitation. Out of these four forces, this one is the weakest force. But it is not like very weak. It's not that it is the weakest force, so it doesn't have any power. It doesn't have any capacity. The entire, like just look at this sun. Look at the solar system. All the planets are moving around the sun. The different types of satellites are moving around the planets. We have an atmosphere which is bound to the earth. Atmosphere is not getting like outside the earth. It is bound to the earth. It is attracted due to gravitation. Like when you are sitting over here, we are here at approximately 25-28 degree latitude. Yeah. So if you look at your position, you are basically hanging here. This building, it is not a straight, it is not on a flat ground. If you look at the building, it is just like this. It is on a tilted manner. It may look straight to you, like the building which is here, or when you are standing, you may think that you are standing vertically on the ground. But in actually, you are not vertically there on the ground. You are always there at an angle. Okay. If there was no gravitation, it would have simply come here. Okay. Think about this, you are always on a tilted axis. And the earth is also not like this. The earth is also like this. So you are more tilted. You are about to fall here. Okay. And think about those who are living in southern hemisphere. Like even Australia, they are just like this, about to fall, about to be projected out of the earth. Okay. So when we look at this universe, if there was no gravitation, nothing like these things would have existed. If you are standing here on the ground, from your point of reference, it may seem that you are just on the ground in a vertical manner. Okay. But you are not actually in that manner. You are on a tilted axis. Okay. You may fall down at any point of time if there is no gravitation. But gravitation enables us to stand on these planets or to be present here. So this is one part about this gravity, that it helps us also. It helps the building to be there. It helps the planets to be there around the sun. The sun is also orbiting around the center of the galaxy. The galaxy is also moving around the center of the universe. The entire universe is rotating. The entire universe is also rotating. Galaxies are rotating. Each and every function of this, it is because of gravitation. So gravitation may be a weak force, but it is the one which is binding all the stars, all the planets together. Galaxies are not a physical object. Galaxies are formed just because of gravitational force. The gravitation makes a galaxy. Due to this gravitation only we have the existence of galaxies. Otherwise, there was no existence of them. So gravity may be one of the weakest force out of these four, but it is not so weak. It is still quite powerful. Now one thing, we know that gravity is impacting the matter. If anything is matter, they will have mass. Basic definition of matter is something which has mass and occupies some volume. That is matter. But can gravity impact energy? Like suppose light is coming here. So can it be impacted by gravity? Can this gravity impact the energy like light? Light which is moving at a speed of 3 into 10 to the power 8 meter per second. So we see that gravity is something which is impacting light also, or it is impacting energy also. Now the question is why? There is one simple thing. We see that matter and energy are two different things. But in fact, what we know that matter and energy are interconvertible. Matter can be converted into energy, energy can be converted into matter. When the universe first started, there was no matter, there was only energy. Energy got converted in the matter. So at the beginning of the universe, there was no such matter, no hydrogen, no helium, no electron, no proton. There was only energy. Energy got converted in form of matter. So this matter, it has also an impact, or the gravitation due to matter has also an impact on the energy. And if you want to see its example, we see it with the help of telescope. Like suppose here we have a star. A star are like this only. Stars are a spherical body. In gift shop you will find stars like that, but in actual stars are spherical bodies. So what we see that here we are observing it using a telescope. Here are multiple stars which may be present here. We are trying to observe them. We are trying to observe them through telescopes. Now generally there is vacuum all over here. Suppose we have this in the like space. We are having this telescope in the space. So there is vacuum all around. There is no air which can cause refraction. There is no air which is going to cause any refraction or any such change. So light should have come in a straight manner. Light should have come from here in a straight manner. This should have been the original path of the light. But what we see that the light sometimes it bends. The light is bending from its original position. And there is no matter over here. In this case, there is no matter. Still, the light is bending from its path. So, telescope will think that the star may be here. The telescope may think that the star is here. Why? Because there is a change in the path of the light. And we always see in a straight line. So this telescope will imagine that the star is here, but the actual position, this is the actual position. And this is the apparent position. Why the apparent position? Because light is bending over here. Why is the light bending? Light is bending because of the gravitational attraction. There might be presence of a black hole here, or there might also be presence of dark matter over there, or there may be a presence of a very heavy, very powerful neutron star. So due to any factor, it may be here. It can be either a dark matter, it can be black hole, or it can be neutron star. Due to any factor, there is bending of light. And this bending is what we call as gravitational lensing. This bending is what we call as gravitational lensing. Okay. So light can also bend. The light can also bend due to gravity. So gravity has an impact on matter also. Gravity has an impact on energy also. Normally light always moves in a straight direction. But there can be bending of light also because of gravitation. It can be because of dark matter, can be because of black hole, can be of neutron star, but it will bend. So this is one thing which we see here, that in universe, even a powerful energy like light, which is considered as most powerful energy source known to humans, which is the most powerful source known to humans. So even that is bending in the universe. So this is called as gravitational lensing. So this is one part, that gravitation is not so weak. Gravitation is still quite much powerful. There is one more part here. There is one thing called as gravitational wave. There is one thing called as gravitational wave also. So now just to see one thing here. Suppose that there are two stars. There are two stars. If they come close to each other, and if they are about to collide, if there are two stars, they are coming close to each other, they are encircling each other. They are like encircling each other. Like earlier they were very much far away from each other, but now they have come close. Now they have come close. And maybe in future they are going to collide with each other. They are going to collide with each other. So when they are coming close to each other, there is going to be intense amount of energy which is going to be released in the space, in the universe. When they will collide, they will release intense amount of energy in the space. Like just to take one example, suppose you have got two different stones. Okay, you have got two different stones. Take a large bucket of water and do one thing. Bring one stone from one side, bring another stone from other side. Try to collide them. Due to their collision, you will find that ripples will be created in that bucket. You will find a wave which is going to be created in that bucket. So then you will find that the wave will start traveling in all the direction. In same manner, there are two heavy objects in the universe. When they will collide, it will generate energy. And that energy is going to propagate in the form of wave in the entire universe. It means the universe will be making the wave. The entire universe, the entire space, it will be making the wave. So all the objects, the stars, the planets, they will be moving across that wave. And there is a chance that, like, if there is a nearby object, if there is a nearby object, if it comes in that path, that object will fragment away. That object is going to be destroyed. Like, suppose if there is a tsunami in the sea, if there is a tsunami in the sea, and at that moment, if there is a ship, if there is a boat which is in the middle of the sea, can it survive there? And how the tsunami is created? Just by a volcano. Just by a volcano. Think about a neutron star. Just to give you an idea, one simple volcano can create tsunami. On Earth, there can be thousands of volcanoes at one time. Earth is just like not even 1%. Earth is like 0.001% of Sun. And Sun is not even 0.001% of neutron star. So neutron star is very much heavy. And suppose two neutron stars are colliding. So from that, how much energy will be generated? Just see one more thing. Suppose this is Sun, this is Earth. The distance between Sun and Earth is 15 crore kilometer. If this is the extent of solar system, it is 30 lakh crore kilometer approximately. It is 30 lakh crore kilometer. 30 lakh crore kilometer. That is the size of the entire solar system. 30 lakh crore kilometer. Now think about this. A star is of the same size. A star which is of same size. And the same size star collapses and forms a dense object which is like 10 kilometer, having a diameter of only 10 kilometer. A star which was of size 30 lakh crore kilometer, it has collapsed, it has shrunk and formed a tiny ball of just 10 kilometer in diameter. So can you imagine how will be the density? What much will be the density of that object? It is beyond the imagination. One teaspoon of the soil of this neutron star may be having more mass than the Earth. Not any object. One spoon of salt from this neutron star may be more heavier than the entire Earth. And if these two objects are colliding, if there is a collision of two neutron stars like this, we can imagine how much energy is generated. This energy which will be generated from here, it is called as gravitational wave. The wave created in the space, in the universe, due to collision or due to orbiting of two very heavy objects, is what we call as gravitational wave. And when you are sitting here or when you are sitting at your home, each and every moment, some gravitational wave is passing through you. The gravitational wave is continuously passing through us. But these gravitational waves have come from millions and millions of light years away from us. So we are not having any impact. If there is even a single gravitational wave created in the vicinity of 30 lakh crore kilometer, it will destroy the entire solar system. It cannot just harm the planets. It will destroy the entire solar system. So then there will be no such need of preparing for climate change. Okay. And then the DART mission and other things will not even work. We have got asteroid deflection test and everything. So if there is a gravitational wave generated in the vicinity of solar system, where it will take hundreds of years for us to reach there outside this solar system. It may take hundreds of years to reach out of the solar system for us. And if a wave is created there also, it will disrupt the sun itself. Forget the planet like the Earth or Jupiter or others. There will be no existence of sun itself. Okay. So that much powerful is the gravitational wave. So gravity is a weak force, but don't consider it to be so much weak. It is a very powerful force which can which can form different things. It is responsible for formation of stars. It is responsible for formation of planets, formation of galaxies, and many other things. But at the same time, it can destroy them also. So that is the power of gravitational force. Here you have to understand at least two different things. One is gravitational lensing. Second part is this: what is gravitational wave? The wave generated due to the collision of two heavenly objects, very heavy objects, and at the same time, even if they are orbiting, that can also cause this gravitational wave. So these are two parts. Once in 2016 or 17, UPSC has asked a very simple question. That question was having just a very simple part, that which of them is true, and one of the line was that gravitational is the strongest force. Okay, so we have to find out which one is incorrect. Perhaps that was the question. So it was very easy that you can easily eliminate this. But UPSC was kind in 2015-16. It is 2025 now. They consider you to be super brilliant. Okay. So now UPSC consider that the new generation is very much brilliant. So we have to increase our level to meet the intellectual level of the new generation. Okay. So that's why they are raising the level of questions just to suit according to your needs. So here they might be asking now about, they have also asked about gravitational lensing. They have already asked about the gravitational lensing. So now there is a chance that this gravitational wave may be the possible question. So gravitation as the weakest force has already been asked. The lensing part, it was asked in 2021 approximately. And now there is a chance that they can ask you about the gravitational wave also. Okay. So this is one topic. First, write about this. Neutron star formation. Collision. Collision is occurring on regular basis. Like in the entire galaxy also. I'm not talking even about the universe. In universe, there are like millions and millions of neutron stars. But when we talk about the galaxy also, gravitational waves are being created regularly. Because there is two things. Either neutron stars will be colliding, or one neutron star, one black hole, two black holes merging with each other. So recently we have seen that a few weeks ago, there was discovery of two black holes which were orbiting each other. Even if two black holes are orbiting each other, then also it can create gravitational waves. So this is going on in continuous manner. But for us to identify it is one of the biggest challenge. We have got one observatory called as LIGO observatory. So LIGO observatory is trying to find out these gravitational waves. There is planning of a building of LIGO observatory in India also, in Maharashtra. But it will take time. Like in the next 1 decade, it might be created. So LIGO observatory is one such thing which is used for detecting this gravitational waves. So write about gravitation. First write this one thing. There are 4 fundamental forces of nature. There are 4 fundamental forces of nature. And write about them: gravitational force, electromagnetic force, strong nuclear force, weak nuclear force. There are 4 fundamental forces of nature. UPSC has misconception about us. Okay, write about this gravitational force. It is a force. It is a force by virtue of mass. It is a force by virtue of mass. It is an attractive force. It is an attractive force. Third part, it is the weakest force. It is the weakest force. It is the weakest force among the four forces of nature. Among the four forces of nature. It is responsible for formation of planets, stars, black hole, galaxies, etc. etc. Black hole, galaxies, etc. It is also responsible for revolution of planets, stars, or galaxies. Planets, stars, or galaxies. I think in geography you may have read this, that tides are also created due to gravitation. Yeah. Right, next part. The gravity can also impact light. The gravity can also impact light. When the light rays passes near to or nearby, a dense and heavy object, such as neutron star, black hole, or dark matter, then there is a deviation in the path of light. It is called as gravitational lensing. We will discuss about them later when we are reading the universe section. Then we will see each and every of them. What is neutron star? What is black hole? What is dark matter? We will discuss them later. Okay. So this is one part. What is gravitational lensing? Write one more part. Give one heading. Gravitational wave. Give one heading. Gravitational wave. When two highly dense objects in bracket, again you can write neutron star or black hole. When two highly dense object, neutron star or black hole, starts orbiting each other, or collides with each other, then it generates enormous amount of energy in the universe. Then it generates enormous amount of energy in the universe. This energy passes in the form of passes in the forms of space-time fabric. Passes in the form of space-time fabric. Space-time fabric. Space-time fabric of the universe. It is called as gravitational waves. Just understand one thing about here, the space-time. See, normally we consider time here on the surface of surface of Earth. We consider the time like it is 24 hours, 12 hours. We even consider this is up, this is down, north, east, south, west. But in the case of universe, there is no north, there is no south, no top, no bottom. Each and everything is at same level. There is no direction, no east, no west. So you cannot calculate east or west in the universe. It is simply in all the directions. You cannot calculate which one is east, which one is west, north or south. We show that this is the upper portion of Earth. But if you look from space, it is not the upper portion. There is no up, no down in the space. Okay. At the same time, there is no concept of 24 hours or 12 hours. For us, it is a concept of 24 hours. The days of 24 hours, day and night is of 24 hours. Because we have calculated it as per the movement of the sun for our convenience. In the space, there is no such concept of 24 hours time. In fact, at certain moment, the time may be stretched. At a certain moment, time may collapse. Like in the case of black hole, time ends abruptly. There is no concept of time over there. That after a certain point, time vanishes. And in some certain part, time stretches. So 1 hour may seem to be 6 hours or 6 years or 6 decades, centuries, millennia. And at one time, crores of years may shrink to nothing. Yeah. So in universe, there is no concept of time. Like this part, 24 hours or 12 hours. Yeah. So this the entire thing, calculation is for us. So this universe is considered in 4 dimensions. If there is a ripple in the space-time, it means time will also vary. Sometimes time will change. Okay. So the time in the space also changes according to the movement of the space. So it will not remain same that if you are going from 12 a.m. and you are traveling for 12 hours, then you will reach at 12 p.m. This is a concept on Earth. In the universe, if you start at 12 a.m., you can reach after 100 centuries also. Or you can be reaching just in a few seconds and the time may change greatly. Okay. So time vanishes also, time expands also in universe. So that is the space-time fabric. The space-time fabric of the universe changes. Okay. So that is one part time will change here. Time changes over here. So this is one thing, space-time fabric, the 4 dimension. When we say space-time fabric, it means we are considering the 4 dimension. And time will always not remain the same. That's why you have this one thing, some of you have said no physics graduation. Some of you have said physics graduation. You may have read about the special theory of relativity and general theory of relativity. So in that you have to read about this, that how the time varies. And that will give you the concept of time travel also. That sometimes you are traveling for a 30-40 years and still your age will not change. And even by just traveling for a few minutes, your age will greatly vary. Yeah. So this is one thing. In general theory of relativity, you will find this one part, that how the time varies. It is not same. The reference changes. And according to the change in the reference, all these times and other factor also change. Okay. So here, don't go into that. UPSC will not ask about it. Okay. So this is one part. What is there in the case of gravitation? Now, there is one part called as electromagnetic force. Yes. Explosion like? A supernova explosion can create it. Like supernova will also create a explosion that will lead to energy generation. That will also create. So like when a star is exploding, when it is forming in the supernova, what we will have? Either a neutron star or we will have a black hole. So during this part also, when the entire matter is collapsing or it is exploding, that can also generate. So supernova ultimately results, like it is a part and parcel of this process, neutron star formation or black hole formation. So here we have this one thing, electromagnetic force. So why do we have the electromagnetic force? Like there is two part of it. One electric force, one is magnetic force. There is two part of it. One is electric, one is magnetic. So now the question is why we are having this electric force or magnetic force? What is the reason behind it? For electric force, I think all of you know this one part, that there are certain things called as charge. Okay. In case of positive and positive charge, there is going to be repulsion. Positive and negative, there is going to be attraction. Okay. So electric force is due to the presence of different charges. But what about magnetic force? Like why do we have the magnetic force? Okay. But why? See, you know that, like you may be aware about this concept of electricity. When there is a flow of charge, if the electron is moving, you know that electron only moves, proton doesn't move like that. Electron is the one which is actually moving. If proton is moving, it means the ion is moving, the entire atom is moving. So when we see that, when there is a movement of electron, we call it as a electric current, or we also call it as part of electric force which is moving. It is creating an electric force around it. But why do we have the magnetism? What is the source of magnetism? Why the electricity creates magnetism? See, there is one thing. If there is an atom, you know that here we have the proton, neutron, and here we are having the electrons. When the electron is moving from its position, we classify that simply as the electric force or the electric current. But remember one thing, the electron is never static. The electron which is present here, it is never static. It is continuously oscillating on its own position. Like suppose if this object is there, you may say this that it is static. But quantum may say that it is static also, it is in motion also. Yeah. The same thing goes with electron. It was initially believed that electron is in a static phase, but later on it was realized electron is never in the static phase, it is continuously oscillating. And due to this oscillation, another electric field itself is generated. But suppose if this electric field is in the horizontal direction, a perpendicular direction force is created, which initially we have called as magnetic field. So magnetism is not simply magnetism. Magnetism is an electric force but in a perpendicular direction. Okay. So why it is associated with electricity? It is associated with electricity because it is associated with the electron. If the movement of electron is causing electricity, the oscillation of the electron is causing magnetism. That's why we always have this electromagnetic force. Electric force in one direction, magnetic force in a perpendicular direction. So this force is always there because electrons keep on oscillating also, electrons keep on moving also. The force which will be generated, it will be generated in two directions. And that's why it is called as electromagnetic force. You cannot separate electricity from magnetism. Okay. So that's why you can see from magnet we can create electricity, and from electricity we can create electromagnet. So they are always related with each other. The oscillation gives the magnetic field, the horizontal movement gives the electric field. That's why we are having one force which is like a combination of two forces, electric force and magnetic force. Initially we didn't know about it. Initially we thought that there is one thing called as magnetic force which is different. But later on, after the quantum, it was realized that there is no such existence of magnetic force by any other thing. It is just an electric force but in a perpendicular direction. So that is the cause of magnetism. Now the question is, in this bottle also we have electrons, but why it is not showing the magnetism? In this bottle also we have electrons, they are also oscillating, but why this is not showing this magnetism? If I if I put it here, it attracts this, there is a magnetism in that portion. But if I keep the bottle over there, it is not attracting. So why certain objects have magnetism and others have not? There are only three objects naturally which shows magnetism: iron, cobalt, nickel. There are three substances which are naturally showing magnetism. The remaining 89 naturally occurring elements, they are not showing magnetism. Why? Everyone is having oscillation. So why they are not showing it? Even this plastic bottle, there is one answer that they are not ferromagnetic. So I am asking that only, why they are not ferromagnetic? Ferromagnetic means they show the property of magnetism. I am not asking what is ferromagnetic, paramagnetic, diamagnetic. I am asking why magnetism in certain substances, why not in other substances? It is all about the sum total of oscillation. Now suppose that in different objects there are electrons. All of the electrons are oscillating. But naturally what we see that due to the position of electrons and due to the direction of their rotation, the total sum becomes zero in most of the substances. In 89 of the substances, the net result becomes zero. They're moving in opposite directions, so they cancel out each other. So there is zero effect. But what we see that in three substances, iron, cobalt, and nickel, we see that their net force is not zero, hence they are able to show this magnetic properties. So it is about the oscillation only. But in most of the substances, oscillation has zero impact because they are cancelling out each other due to their position, due to their rotation. But in three substances, it doesn't happen: iron, cobalt, and nickel. So that's why we have some substances showing magnetism and other substances not showing magnetism. But see this one thing. Let us say we have a copper wire. Copper is not magnetic. You know that copper is not showing magnetism. But if we pass electricity through this, will it show magnetism or not? When electricity is passed through it, it is going to show the magnetism. Why? Because we have changed the original position of the electrons. When electricity is passing through this, suppose the electrons were in this position, their position is going to vary now. It is going to change. And as long as it is changing continuously, then they will have magnetism. Otherwise, they will not have magnetism. So magnetism is a result of electrons. Like the electric current is a result of electrons, in same manner, magnetism is also a result of electrons. So that's why we have a combined force, electromagnetic force. So its origin is because of electrons only. Its origin is because of electrons only. And now see this one very important part. Like the light which we also see, it is also electromagnetic wave. Wave means it is an energy. It is an energy which is created as a result of electromagnetism. Means there was an electric force and a magnetic force which resulted in formation of an energy called as light. Okay. But light is not positive or negative because it is an energy. Energy is a scalar. Okay. So it is neither positive nor negative. But what we see here, that it is a result of electromagnetic interaction. Okay. So electromagnetic force, if we look at this is a force which is caused due to interaction between the electric and magnetic force, or it is a resultant of electric and magnetic force due to the electrons oscillation and movement. Now, one more thing. If we talk about this force, it is the second strongest force in nature. Not the largest, but it is the second strongest force in nature. How much powerful this force is? How much power? Just to give you an idea, gravity, we have seen it is very powerful. Electromagnetic force is the force which can lift a train with thousands of people from the ground with the help of this force. There is a type of train called as maglev train. A type of train called as maglev train. In China, in Japan, in other countries, you will find there is a train called as maglev. Maglev stands for magnetic levitation. So with the help of electromagnetism, they lift the entire train full of passengers. And that train travels in air. Okay. It is not traveling on the track. It is traveling in the air. Not in vacuum, in open air. Just it is like above the track. So first the train gets its original speed. First it goes into the motion, and then with the help of electromagnetic force, it is lifted. Why lifted? Because on the track there is going to be friction. Friction reduces the speed, friction reduces the time. Like it reduces the, it is harming the track also, it is harming the wheels also. So we lift the train from the ground. The train is moving in the air. It is moving in the air just because of application of electromagnetic force. So that train acquires a speed of like 500, 600 km per hour. So this is the power of electromagnetic force. Like they can lift something against the gravity. And think about this, a train is going to be a very heavy object, and that too of thousands of people who are there, and it is lifting the entire train in the air. So that is the capacity of electromagnetic force. It can act against the gravitation and it can lift the entire thing. So that is one such example that how much powerful it is. Electromagnetic force is also this like a force responsible for existing of the atoms. Okay. The atoms have got all the protons and electrons. The forces between them bind them together. That is binding them together so that they can exist. They can form an atom. So that is also one part. So this electromagnetic force is the second largest force, second most powerful force. Now there is one more part. If we look at gravitation, gravitation is having like infinite range. Gravitation is having infinite range. Just to give you an idea, we are here on the earth, but there is a center of universe. That center of universe is not like nearby. Perhaps we will not be able to reach there in millions and millions of years, and even more. The light which is traveling at 3 into 10 to the power 8 meter per second takes more than billions of years to move from one part of universe to other part. Like a light which has been generated 5.5 or 6 billion years ago is reaching to us in the present time. From this you can imagine what is the extent of universe. Light is traveling at 3 lakh kilometer per second. We cannot even go near that speed. We cannot even go near that speed. Light is traveling at 3 lakh kilometer per second, and still it is taking light forever to cross the universe. Light is not able to cross the universe. Light has not been able to cross the universe. In fact, it has taken light billions of years just to reach from one point to another. So we will not be able to go to the center of universe ever. But the impact of gravitation is from that point of singularity to the farthest extent of universe. That is the range of gravitation. So gravitation is infinite. To the entire extent of the universe, there is gravitation. Now, if we compare to that, electromagnetic force is not having that much huge range. So electromagnetic force is not having that much range. You can lift the train by a few centimeters, but you cannot throw it out of the gravity. You cannot throw it like out of the surface of the earth. So the range of electromagnetic force is not that much enormous. So this is the second part. Its range, if we compare the range of it, it is not as infinite as the gravitation. Its range is smaller. It is more powerful, but in a small range. It is not in infinite range. So that is another part. This is having an infinite range, but this is having a finite range. It is up to a certain level only. Suppose there is a electric grid also. The electric grid is releasing electric force. Will it impact you if you are passing 1 kilometer away from that area? If there is an electric grid and you are passing even 100 meters away from that, will that cause impact on you? So electric force is going to have a limited impact. If you are in vicinity, sometimes with the help of moisture, it can impact you. If you go near it, it might attract you with the help of this moisture and all. But if you are far away from it, even if you are away like 50 meters, then also there is going to be no impact. But the gravitation, it has impact to an infinite range. The moon, which is like 4 lakh kilometers, a small object, moon, it is having impact on the oceans on the earth. So gravitation is weak, but infinite range. Electromagnetic is second strongest, but limited range. Okay. So this is the second force, electromagnetic force, which is present in the nature. Okay. Now, write a little bit about this. Electromagnetic force is a result of interaction. It is a result of interaction between the electric and magnetic property of substances. Electric and magnetic property of substances. The electric property, the electric property is due to the movement of charge, whereas the electric property is due to the movement of charge, whereas the magnetic property is due to oscillation, of charge. The magnetic property is due to oscillation of charge. The electric and magnetic force, are perpendicular to each other. The electric and magnetic force are perpendicular to each other. The electromagnetic force is the second strongest force in the nature. The electromagnetic force is the second strongest force in the nature. However, its range is smaller. Its range is limited as compared to the gravitational force. जहां पे आपने ऑसिलेशन लिखा है ना, वहां पे ब्रैकेट में रोटेशन लिख लेना. So this is the second force. Okay. Now we have to see these two forces, strong nuclear force and weak nuclear force. So just to give you one simple idea, although we will discuss that in detail tomorrow, but just to give you a simple idea, if there is no strong nuclear force, then there is nothing. Like if there is no strong nuclear force, then there is no existence of all the things which you see. Yeah. There is no air, there is no matter, there is no substance, there is no atom. Yeah. So a strong nuclear force is the one which makes the proton and neutron. Without proton and neutron, there will not be any atom. Without atom, there is going to be no substance, whether it is solid, liquid, or gas. Yeah. The strong nuclear force is the one which leads to formation of this atom. Yeah. Matter may have existed, like some amount of matter may have existed, but not in the form which you see today. It's not that first there was direct formation of atom itself. It is our concept that atom was the beginning, but atom was not the beginning. Not even electron, proton was the beginning. There was some subatomic particles, subatomic things which have been created first, and later on there was the formation of the proton, neutron, and electron. So these things have formed later. The force which was responsible behind the formation of proton or neutron is our strong nuclear force. So this is the strongest force. If any force becomes more powerful than this, it means there is going to be destruction of the concept of neutron itself. The neutron will collapse, the protons will collapse, and there will not be the atom, there will not be the matter which we see today. All these buildings, all these planets, all these stars, all these galaxies which you see, it is because of a strong nuclear force. Okay. And weak nuclear force is the one which is responsible for conversion of a proton into neutron or neutron into proton. So this is one part which we will see in tomorrow's session, that what is the strong nuclear force, why it is the strongest, why it has to be strongest, and then we will see the weak nuclear force, which is the third strongest. It has got the name weak, but it is not the weakest. Okay. So everything which has a weak name is not the weakest force. It is the third strongest force. The weakest one is gravitation. And you have seen how much powerful gravitation is. Okay. So gravitation is more powerful than many forces which you know. Okay. Then you can imagine that how much strong is a strong nuclear force. And then weak nuclear force is also stronger than gravitation. But they have very limited range. They are having range of like the matter, like suppose that, have you seen atom? Have you seen molecules? Yeah. They have not seen atoms or molecules. Think about this. Within the atom, there is one thing called as nucleus. And within that nucleus, there is something called as proton and neutron. So inside that proton and neutron, the force that is acting, it is the strong nuclear force. You can compare the range of it. Like at least electromagnetic force was having some range. But if you compare the strong nuclear force and weak nuclear force, they have exceptionally very small range. They are not even in centimeter or millimeter or like nanometer. They are even at further lower scale. That is their range. Okay. So in that case, it is the strongest. In that small range, it is the strongest force. Nothing can change that. Okay. So that is one part. Let me first take some questions. If you have any question from online section, if friction is not increasing the time, I corrected that part. That friction leads to like damaging of the products. पाताल लोक में दूसरी फोर्सेस लगती है. Many similarity between DNA and genetic material. There is any difference? Genetic material is the broader concept. Out of that, DNA is one part. Genetic material includes DNA, RNA, proteins, each and every part. One segment of that genetic material is DNA. Gravitational force is weak when we compare to them. When we compare to them, they are the weak. Like gravitational force is weak, but it is not like a very weak force. It is much more powerful. Does all celestial bodies have their own gravitational force? I am telling about not even celestial bodies. I am saying this pen is also having gravitational force. If you are having a pen in your home or if you are having your notebook, that is also having gravitational force. It can be negligible. So all celestial objects which are there, they are much more larger. Of course, they will have gravitational force. Sound waves कभी end होती है. Like energy is, like you know that energy is neither created nor destroyed. It is only getting transformed from one thing to another. Like suppose that if light is coming to you, it doesn't mean light ends here. It is getting transformed in other form. Or if you are hearing sound also, it is getting transformed in other form. Gravity applies to light. Yes, I have told you gravitational lensing. It will not be applicable on Earth as such because in Earth there is not that much gravitation. On Earth you will not find that much gravitation which can bend the light. But when you see the black holes, when you see the neutron stars, which are heavier objects, they can bend the light. No, refraction is not called lensing. Refraction is refraction due to air, due to density. That is not lensing. Gravitational lensing is due to the gravitational force. There is no change of medium because there is vacuum over there. We will come to that. We will come to the cosmic part when we will see the universe section. See, anything which is in the cosmos is called as cosmic wave. Cosmic wave includes everything. Anything which is there in the cosmos, like the universe is called as cosmos. If gravitational range is infinite, then why does universe is expanding at higher speed? We will see that in universe part. Just to give you one idea, like all the stars which you know, all the galaxies which you have never even heard of, all the like countless stars and all the energy combined together becomes only 5% of universe. That's why universe is expanding. and universe is expanding at a rate which is even much more faster than the light. The universe is not expanding like 1 centimeter per year. It is expanding more than the speed of light per second, per, like, there is not even concept of second there. Okay. Vectors, yes, vectors are just the carriers. In the vectors, it can be one such ordinary virus which is not impacting us. Does every country has different criteria of providing patent? Every country is having somewhat different, but there is one thing called as TRIPS. The TRIPS has given one guideline. When we will see the science and tech part, we have to read this one chapter, intellectual property. There we will see that in detail. Okay, so we will meet then tomorrow, and then we will start from here. Thank you everyone. Take care.